Good afternoon, folks. We are going to finish up the part 3 and work on part 4 today. So there was only one little piece that we need to talk about in chapter 3, or I guess section 3. These PowerPoints are just a collection of all the things that I think are important to understand. Okay, we talked about order by, limit, the like operator, and we need to just look at two more things actually. Aliases and then the insert into select statement. So aliases are very simple but extremely useful. So here I'm gonna, I did post the aggregate functions homework, which will be the final homework assignment with a starting point, and I'll just be using that starting point for the demo here, so you guys can get used to it, because it's a little bit different than the other one. In the school database. All right. So this database contains information for a business that wants to keep track of its sales. So we have tables for customers. We have tables for, we have a table for the sales records. We have a table for the products records, and we have a table for something called line items. I think I have the ER diagram in here. I want to add that in for you guys. That makes it a lot easier to figure out the relationships and see how things are connected for the joining. All right, we'll have to throw it together, but we could talk about it here. That'll probably make more sense anyway, and then I'll add it in. All right, I'm going to start with the, I saw this before, where is it? Here we go, the basic ER diagram here. All right, so we have customers, we have sales, we have line items, and we need one more for products. And I'm just so we can get some experience using this, I've decided to use for this ER diagram and the previous one the crow's feet notation instead of the what is it called? I think it's Chen's notation. So different ways you can create an ER diagram, and they each have their strengths and weaknesses, but it's important to know both just so you can interpret whatever you end up seeing in whatever you end up doing. All right, so the primary key of customers is we'll use the actual code here. CID for customer ID. Right. I'm only going to include the primary keys and foreign keys in this diagram because that's all we'll be using it for, is to do our joins to get the information we need. So we got customers, and next is sales, which is has a primary key of sale ID and a foreign key of CID. What do you think that's telling us? If we have a foreign key of CID, we have a foreign key in sales of CID, and that's the primary key of customers. What can you say about that relationship? A single customer can have many sales because each sale will store the customer ID of whoever participated in that. So if customer 1 bought something, then we would create a new record, and the foreign key would be 1 because that's the ID of the customer. If they purchased more things, it would create another SID for that new sale, but the foreign key would still be 1. All right, so that's a one-to-many. All right, sales. All right, so line items actually has 2 foreign keys. And then you tell me what kind of table you think this is, because it has SID and PID. SID is sales ID. PID is actually product ID from the products table. Okay, so it has those 2 foreign keys, and then it has a quantity field. So we know that SID is a foreign key and PID is a foreign key. But what is the primary key of that table, do you think? No, that's actually correct. Okay. And this one needs to be one to many. So here's our ER diagram. We'll have we have 4 tables. We can see the relationships between these tables. So if we wanted to find out which customers bought which products, how many tables would we need to join together? We can't just connect customers to products because a customer record just tells us information about a customer. It doesn't have any information about what they bought. The products table only has information about a single each record is a single product. has no idea what a customer is. There's no information relating it to that. But customers is related to sales, and sales is related to line items, and products is related to line items. So you would actually have to join all 4 of these to get that if you want to see, you know, which customer purchased which products. And this is where we can start talking about data mining. All right, knowing who bought what when allows you to look for patterns, and you can use those patterns to make business decisions. The more data you have, the more accurate your patterns can be. All right. Oops, used the wrong end here. There it is. I think they have it as curved. There we go. This is so important, right? Okay. So we'll save that. And I will put it in the assignment for you guys to use. Well, we'll use it today too, in this video. Let's put shadows on it. See how that looks. Databases. Now we'll stick it in here. Throw that in the assignment. There we go. So now that's in there. Ooh, fancy shadows. Okay. So now you guys have the questions here. You have the starting point here. You have the ER diagram to help you figure out the joins. And for each question, I've given you the solution. So if you write the query correctly, this is what you'll see for number 1. See these. I'm sure you guys figured that out in the last one. That gives you something to check against, because that's what I'm going to be looking for when I run it. But I'll go into the code to make sure that you're doing it right, or give you tips. In the last video, I was accidentally showing just the top of my head, so I'm trying to be more cognizant of not that you guys want to see me anyway. Okay. So we got that. All right, so that's all ready. So now back to the topics. So aliases in SQL. What is it? Well, you know how when we print out a table and it shows the field names? Sometimes those aren't very good, right? So I'm going to select star from line items, and I got to have headers on. So I'm going to update this with a little bit of the SQLite stuff we added in the other starting point. So I've been finding a lot more useful functions in the SQLite dot commands. So I might use some of those, and I'll try to explain what I'm doing. One cool thing that you can do is, instead of using SQL to print stuff to the console, you can actually just use .print. And I'm not sure if this works. Yeah, I think this works. But we can just put like first query. And then, whoops, it's actually just this. Wrong language. So there it is. We can just put stuff right in there. So you can label your exercises. This makes it easier for me to grade. But it's not a requirement right now. So anyway, aliases. So here's SID, PID, and quantity. If you printed this out and gave it to someone that didn't know what those fields were, then it wouldn't be very useful, right? Maybe they would say SID, PID, and you can't even pronounce that, right? So what we can do is we can actually use an alias and rename the output field name in the output. So we can do SID, let's do line items dot SID as, what was it, SID, sale ID, right? Sale ID. We can do the same thing for the others. There we go. So using this, we can see the first sale had product number 1. Wait a second. Not product ID. Oh, yeah. Sorry, I forgot what table we were printing out. Okay, so in sale 1, there was 1 of item 1. In sale 1, there was 1 of item 2. And then the last thing in sale 1 was 1 of item 3. So the way we have it set up, we can include multiple types of products in each sale, but we can also include how many of each. All right, so you can see, this requires a lot of extra typing in your select statement, but if you want to change those, you can do that here. You can also use this on table names. So I could put line items as L, and then I can just refer to this in the query as L. Okay, so that makes it a lot shorter here. And so this is really useful on joins, because you're going to have to use the table names and the table names with the properties for the foreign key. All right, so that can shorten your queries and make it easier to read. All right. And if you have a longer set of fields like this and you want to make it easier to read, you can even format it like this. And then it's much easier to see, okay, we're selecting this column, and this column. And we're naming it like this. And SQL doesn't care about the white space. So spaces, line returns, tabs, it'll ignore that unless you put it in double quotes. So because this message has spaces, well, for the print you have to put it in double quotes. And remember, this isn't the SQL, this is just a SQLite dot command, like we're using up here. When you use an alias, if you want to use a space in it, you have to put it in double quotes. An alternative could be putting it in, well, I don't know in SQLite if you have to use, yeah, if it's some one word of characters without any spaces, you don't have to put the double quotes. So it just depends on your output. But if you want spaces to be recognized by SQL, you have to put in double quotes. All right. So that's as simple as aliases are. And I'll continue to use those as we look at doing the joins. All right. The other one is a powerful tool. It's called insert into select. So what this allows you to do is copy the results of a select statement into an insert statement to add data to a table. So if we want to add some information to a table, create table, copy of products. We can do that. Don't forget your semicolons like I do all the time. Sorry, I was creating functions earlier in a different class and those use curly braces. All right. So we can create that table. It's going to be empty, right? Select star from copy of products. All right, so it doesn't show anything because there's nothing in there yet. Let's write a statement that'll copy the values from the products table into this copy of products table. Okay. And so to do that, we have to write a statement. It's an insert into and then instead of providing values, you just include a select statement. Well, I'm not going to copy it out of the PowerPoint because we know what happens if I do that. All right, so we're going to do insert into the new table, copy of products. All right, and we need to make sure our result has data in this order, int, varchar, int. So that'll be easy because that's what it's already in the other table, but we'll do the insert into, and then we just do select. And so we're just going to select the three fields. Actually, products, how many fields does products have? did I copy the right one? Yeah, PID, pname, price. PID, pname, price. Okay. If you see me looking down, I'm just checking to make sure no one's talking in chat. As always, ask questions if you're not sure of something. So we're going to need to grab p.pid, p.pname, and p.price from products, and we'll call that p. Oh, forgot my semicolon again. And now the copy of products has those records inserted. All right, and that, you know, here with only 3 records, it's not that big of a deal, but if we have a lot of records, we can save time. I wonder if this will work. So there's this command here that you can use in SQLite called .dump. What that does is it writes the SQL to recreate the database from whatever information is added. So here, it's like exporting. So it looks at what are all the tables. It creates a create table for every table. It creates an insert into for every record. So here's the customers table. Here are the inserts, sales table, inserts, yada, yada, yada. And then right here, copy of products, it's the same as the stuff that we had for products. Okay, you know, copying a table from one to another, copying the records from one table to another may not be apparent why it's useful, but it's good if you need a copy of the data to run some tests on and you don't want to mess up the existing data. It can be a useful thing to do. All right, and then you can do .dump, and I think you can even specify the table name. Copy of products. And then that will only show you the the DDL to set up that table with those values. If you have a problem with the console not clearing your code in SQL, there's also another command that you can use. And it is in the other example that I put up in the class, which I haven't gone over yet. I think I did it in here. Where did I put that? Anyway, I'll find that later. You can Google it too. But you just put that at the top and it'll clear the console. There's a command to clear the console, and then you won't have to remember to click this button every time. But it seems to not be doing that this time, so that's nice. Anyway, I'm going to stop dumping. Let's get rid of that. Okay, and so there we go. This stuff up here was aliases. And this stuff was the insert into select example. So I'm just going to minimize these queries, and we'll just comment this out for now. So we can move on to the next thing. And I want to remember, I do want to do a insert into with some different with joins. See how we can pull information from multiple tables and store it in a new table. Okay, so I think that's it for the part 3. So we're ready to talk about aggregate functions in part 4. Alright, so because we're working with data, we want to be able to combine it in different ways and manipulate it to get what we want, so that we can get more useful information and we can do things on the database side where they're faster instead of having to send more information through the network and have to have the developer include ways to do that in the code. Okay. So we're going to take a look at the following aggregate functions. And so what these do is they combine records together. So if you have records that have numeric values as a field, you can find an average of that field between records. You can use count on any field to count the number of records in a table or the number of records in a result. The max and the min return the highest or lowest value within a set of numeric values and records, and some will just add them all together. All right. So let's just go through these with a few examples, and we have to use this database because the other one didn't have any numeric data. And so let's say we'll just focus on the products table because it has the price field, which is an integer, so that means we can perform arithmetic on it and use these aggregate functions. Okay, so this will be count. All right, so we're going to select, and then whichever field you want to use the aggregate function on, you just put the name and then you put the field inside. So we were going to count the price. We were going to count, this is what this is going to do is count the number of records in the product table. And so it doesn't matter what field you use, but it's typically you would use the ID. Oops. So that would be p.pid from products that will give the alias of p. All right, so this is saying there are 3 records in there. All right. You notice the field name is kind of a mess. This is why I was showing you the aliases. Because, you know, if you know what the count function does, you could probably guess that this is telling you how many records there are in the products table. But if you don't, it might be good to label it to make it easy to see. So total products, we have 3 total products in the database. All right. Now let's take a look at using count with a join. All right. Maybe. Let's see. What do we want to do? We want to find, let's count, well, I think I don't do group by until later. So let's do another example. Actually, no, we're doing group by now. So let's look at the line items table. We'll do this without a join first, and then we'll do it with a join. Inside of the line items table, our records include which sale, product, and quantity there were in a sale. So in sale 1, like I said earlier, we have 1 of product 1. In sale 1, we also have 1 of product 2 and 1 of product 3. In sale 2, we have 3 of product 1 and 1 of product 2. Okay, that's not very easy to read if you don't memorize what this is, so you could join it together to make it more readable. But for now, we'll just use those numbers. And what we're going to do is we're going to count how many records there are for each product in the line items. Okay, so for example, there's 1, 2, 3, 4 of number 2, and so we know there were 4 sales that had product number 2. But we don't want to have to look at this and count that out. We can write a query to do it for us. So let's start from our other query. Just to save some time, count with join and group by. Okay, so now we are using the line items table, and I'll call it L to make it easier. And so we are going to find we want to count the, actually we don't need to use group by yet. Do we? Yeah, we do. Sorry. We want to count, again, I don't think it matters what field we count on, but let's go ahead and count on the one we're using. So L dot PID, because it's SID, PID, quantity. All right, so we'll have one column that will count the product IDs, and we want those counted by the product IDs. So what we want to see is, for product 1, how many there are, for product 2, how many there are, and etc. So I want to see the actual PID in the result, and then in the next column, I'm going to have it count those PIDs. And I'll use aliases again here. All right. And so if I do it this way, it says product ID 3, there are 11 products. And so this is just telling us that there are 11 entries. Let's make sure. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Or we could have just taken 62 minus 52. Or no, 10. Yeah, it's 10 because it's 10 lines. All right. But that's not what we want. We want to see every product ID here, and then we want it to total only for that product ID. That's where we'll use group by. So when we use an aggregate function like count, sum, or average, we can group those results by sorted by other columns, or combined with the similar values in the same field. So to do that, you just add group by, and then what you do is you put the fields that are not being affected by the aggregate function. So here we're only using the product ID, so we'll do that. And now our result will be product 1 has 4, product 2 has 4, and product 3 has 3. So you can count them if you want. 1 has 1, 2, 3, 4. Okay, so there's that. Now let's add in a join. Maybe I don't want to just see the ID anymore. I want to see the actual name of the product. And we'll actually call this total products by sale. I don't know how to describe this, so that's what I'm going to describe it as, because it's by sale. No, it's by product. Total sales by product. No. We'll just call it total. But it's the total of how many times that product appears in the line items, which tells us, the way we have it set up, how many sales included each product. Okay. So for example, for product 1, there were 4 different sales where people bought product 1, 4 different sales where people bought product 2, and 3 different sales where people bought product 3. So that's what that is. Now we just want to add in the name of the products. So now we go back to our ER diagram. Which is in the assignment. Oh, I have it over here. There we go. And so we need line items because we want to know which products were in which sales so we can count them. But we also, now we need products, because products contains the product name. So we have to join those two tables together. And so if I just do select star from products, and I do select star from line items, we can see when we use those tables, the first thing it does, if we're going to use both of these tables, is it grabs all the records, all right, from each table. Okay, so there are 3 products and there are 10 line items. Okay, those are important numbers to keep in mind. Three records in products, 10 records in, we can just put it here, print 3 records, and here we can do print 10 records. Just put a little space between these. So \n gives you a line return. Okay, it's hanging, so I'm going to copy my code and refresh the page. It's the equivalent of turning it off and on again. the nuclear option. All right, let's see if it kept anything. Did. Okay, now we try it. There we go. Okay, maybe it was working. Oh, no, it didn't include everything. So I'll overwrite that. There we go. Now it's working. So there are 3 records in products, 10 records in line items. Put a little message in there. It's important for this next part to keep that in mind. All right. And I guess I should say this. If you're confused by line items, what we're doing is, at Walmart, if you look at a Walmart receipt, this represents a sale. It has all the information, when it happened, blah, blah, blah. But they're keeping track of which products were in that sale. So this receipt as a whole represents a sale, but each line here represents what product it was, what the price was. Some of them do multiple. So here, this is 4 avocados at 44 cents each. Here's the total for those 4 products. Okay, so that's what we're talking about with line items. We're talking about line items on a receipt. All right, so we want to join those 2 tables together. So let's just try joining them together and see what comes out. Or let's just try grabbing everything out of both tables without using a join. So products, we'll call it P, and then we'll grab line items, call that L. All right, and okay. And remember, we were joining these so we could find the name of each product by its ID. So here's these first 3 columns. Those are the columns from the products table. These 3 columns are from the line items table. Okay, so this is right. Product ID 1 is peach. You can see that down through here. But what's wrong with this record right here? Take a look at it, at all the values in the fields. As I zoom in, because it's really tiny. We don't need this. We do need this. Okay. We'll zoom in again. Whoops. So what's wrong with this record? So peach has a product ID of 1, but the record that it's matching it with in line items is a product ID of 2. So this combination is just junk data. This doesn't mean anything. And you can see that repeated basically all the way down here. All of these records here mean nothing. Oh, wait. Well, yeah. Anywhere where it's not 1. So here, these 2 don't have a product ID. The product IDs don't match. So that means the record from the products table and the record from the line items table aren't related. So why are we putting those together? Okay, so we only want the records where the PIDs match first. So what we're going to do is we're going to filter out all the junk data, and that's where a join comes in. All right, and we only want the records where the PIDs match, okay, and we don't want any records from the products table that aren't involved in line items, and we don't want any records from line items that aren't involved with products. And I have a nice little tool here. This is simple, but it's useful. Let's pretend A is the products table, B is the line items table. So A contains all the records of the products table, B contains all the records of the line items table. What we did by pulling both tables is get all the records multiplied together. So for every record in A, it put every record in B. And then you can see that here. Here's all the all the 1 records, and if you count these, there will be the 10 records from line items, and then here's a record. This is repeated all the way down here for products, and then there's all 10 records here. So this is going to give us 30 records, and only 10 of them. We only want 10 of them. So we can't do it this way. We have to join them. Okay, so we don't want all the records from both. We only want the records where they overlap from both tables. And that's why we're going to use an inner join. So after I've chosen my first table, given it an alias, I'm going to take the result of that, which is these 3 columns on the left, and match them up with all the records in line items. Okay, so here, if we do this, we still get our 30 records. All right. So just by listing them like this, we're still getting all the records. It doesn't know how to filter them out, so we have to tell it. We want it to filter out all the records that don't meet this criteria. P.PID is equal to L.PID. And so by doing that, we're saying only keep the ones where the PID from the first table matches the PID from the second table. And now, I'm going to turn these other ones off because... Oh, I put the number of records here. Now it's not clearing. Okay. Remember we had 10 records in line items and 3 records in products? Well, when we just join those tables without using the foreign key, it gives us 30 results, which is just 3 times 10. So if you join a bunch of tables together, it's going to create a bunch of junk records and waste a bunch of time. But now here I've joined the 2 tables together using an inner join, and I've filtered out all the records that don't meet this criteria. So we can now we'll only see the ones where the PIDs match. This is what we want. Okay. And so here we're selecting all the fields, but we only want to show the product name, and we want to find the count of how many there were. So we can do that by first grabbing the product name. So now we're filtering out which fields we want, because we only need pname and PID. We're going to do a count of PID, and we're going to do we're just going to print out the pname. So we can do p.pname, because the pname field is in the products table, and we called it p down here. So that's our first column. Second column, we'll use that aggregate function to count. We'll do L.PID for this one. All right. And then that's going to give us this thing we had earlier, right? It's just combining all the rows together. But we don't want that. We want but we want it to be by product name. So what can we use? Group by. So we want to say keep the fields that are different in pname. So we can do group by p.pname. Now we can see there were 4 sales that had mangoes, 3 sales that had papaya, and 4 sales that had peaches. All right. And let's throw in more stuff from the last time. Let's say we want to see it by, we want the most popular products at the top. Right now it's showing us 434. We want it to be 443, because imagine if we had more products. We could do order by, which column do we want to do? Well, it'd be annoying to have to type this down there, so we can give it an alias, total, and then we can just do order by total. Okay. Oh. Gotta move my semicolon down. Okay. And so that puts the lowest one. How do we get it to go from highest to lowest? So the default sort is ascending, but we want to use descending, so we can just put a modifier after this. You can either specify ascending, but that's the default, or descending, and that'll put it in this order. So now we have the products in the order of which ones were in the most sales. Okay, and that's very specific information. We can get that using an aggregate function. Okay, so there we showed how to use an aggregate function, how to use group by, and another example of a join. Let's take a look at the other aggregate functions. Okay. Let's take a look at the average function. All right. In the products table, we have product ID. Well, let's just print it out, so you don't have to take my word for it. And just in case I make any mistakes, I can see them. All right, so I'm just going to select star from products. All right, we have PID, PName, and price. Let's write a query that will tell us the average price of our products. Okay, we know we want to add together 5, 3,000, and 7,000 and divide it by 3, but we don't want to have to do that. And what if we add new products with different prices? We don't want to have to keep track of that. We can have the computer calculate that for us. All right, so let's change this to find the average price of our products. So we're no longer going to just select every field. Let's just put the, well, we just want one result, so we can put average, which is the AVG function, and whichever field we want to average, price, and we can get that result. And again, this is the average of the price, but we can use an alias to change that. To something else. So average price of our products. Or if it's a field that you're going to reference in other places, you can give it a very simple name. And then you can reference that wherever you want. All right, let's take a look at the next part. So we could do, this is, you can use this example for basically all the other ones. So we can see an example of average, we can see sum, we can see max, min. Of course, we don't want to use the same aliases on these. Okay, so if we add all the prices together, this is how much it is. If we find the highest one, it's 7,000. The lowest one is 5. Okay. All right. So that's how you use the aggregate functions. Now, what else can you do with these? Because this is, at this point in the class, this is all about refining your queries to get very specific information. We have the ability now to join tables that are related, and we have the ability to apply functions, perform arithmetic, and get basically whatever information we want out of the database. That's what this chapter is about, getting more specific information. All right, so, oops, I keep doing that. We could do, do you remember what the where clause is for? Let's do select star from products where, and we'll call this P. P dot price is greater than 10. Okay, so we had that. So there are two records that have a price greater than 10. Okay, so that allows us to filter the records, take out records in our result. Remember, the select allows us to control how many fields, where the where lets us control how many records, or which records. But if you look back at the example where we were counting, see the one with the join so we can see the name. There we go. Let's take that one. All right. And so this one showed us these results. But what if I want to do only the results that are greater than 3? I don't care about any products that were only part of 3 or less sales. I only want to know the ones that were part of 4 or more sales in my result. So if I try to do that in the where, oops. So any values that are greater than 3, which means it won't include this one. So it says misuse of aggregate count. So what that means is at this point in the query, we don't have access to the total. That won't be available until after we've finished the group by. That's when we have access to the total. So there's another clause, which is basically the where of aggregate functions. And in here you put having total greater than 3. So when you're using group by and an aggregate function, and you want to filter the results from that, you have to use the having clause. And so there, now it's only going to show me the ones that have 4 or more. All right, so that's having. The last thing in the class is using subqueries. And this is as complicated as we're going to go. All right. In this example, we want to use an aggregate function on the result of a table that is using an aggregate function. So in this query, and this one we'll just use the example here, and then we'll break it down. Oh no, I'm copying out of the PowerPoint. I think I have a trick that'll fix that. Okay. See if it breaks. Oh, it worked. So you can see we actually have a query within a query. So let's organize this so it's a little bit easier to read. So we'll put each column from the inner query on its own line. And we'll fix this. Make it a little easier to read. Okay. So we have select from where with a group by. And we're to get the result here. So ultimately what we're doing is we're trying to figure out the total value from each sale. Okay, and that's what this inner query is doing. So let's see what that does first. And I got to fix the joins on this because I was using a different technique here that I don't want you guys to use. Okay. So if we have 3 tables, that means we're going to need to do 2 joins. So sales and line items have SID in common. I'm going to give these some aliases to make this easier to read. So we can call this S inner join on L. So that's saying sales inner join line items on S dot SID equals L dot SID. All right. Actually put that up here. Sales S inner join line items L on that. Okay. Why am I putting it up here? Oh, because I want to close this one for now. Comment this out. We want to focus on just writing a query that will tell us which, this should go back here. There we go. Oh no, these should actually be left alone. And then this one we can bring forward to show that there are these 2 columns. Column 1, column 2. 2 fields. Alright, so this is our first join. This gets us sales joined to line items, but we want to include products so we can get the product names. Actually, no. We need line items because that is the table that has the quantity of products in each sale. Well, products has the price of each product. So we're going to have to multiply the product's price by what the quantity was sold to get the subtotal. All right, and then we'll be doing a sum of those to get the total. Kind of like in the Walmart receipt, right? So here they're saying they got 1.75 pounds of bananas, and the price is 54 cents a pound, so the subtotal of bananas is 95 cents. Here they bought one beverage, so the subtotal of that is 2, and then down here they're adding it all together to get the total of all of the totals calculated here, and we're using sum to add all of these numbers together. That's what we're looking for, and we're going to be doing that per sale. So imagine if we had I think there are 4 sales in there, so basically we're adding up the values on 4 receipts with this query. All right, and we are using a calculated field here, if you remember that from the when we talked about the different types of fields. And this is just arithmetic. It's a here's a integer field multiplied by another integer field, and then those will be summed. All right, so where were we? We have to join. So this is our first join. Okay, and then we need to join the result of that table to the products table. And so I will move that down here to keep it easy to read. Inner join. So it's going to take the result of this join and join that with products on and so you can also give aliases to these. So this is the sales table and the line items table, S and L. Let's call the result of that SL. And so we're going to combine products. We'll call that P on P.PID equal to SL.PID. And then we will be grouping that by, there's only 2 fields, so we're going to group it by sale ID. So S, and we can call the combination of all these joins. We have sales, line items, and products, so let's call it SLP. We want to group by SLP dot SID. All right, so let's see what the result of that looks like. So the inner query is, sorry, I changed all the names from the one on the slide, so I gotta make sure products.price should be p.price and l.quantity. So looking at our result here, sale number 1, we sold $10,005 worth of products. And so we could look up in the line items, insert values. We sold 1 of 2, 1 of 3, and 1 of 1. So 1 of each product was sold in sale 1. And so that should be 5 plus 2,000 plus 7,000. So that's right. And then the other one should be right too, but you can double check if you want. And now I want to say, okay, these were my 6 sales. Maybe I did 1 sale a day for a week, and we have Sunday closed. I want to know, what was my average of this week? So I can compare it to maybe other weeks in the future. All right, so I can use this inner query as a table for another query. So I can just put this in parentheses. Okay, and this might actually be an easier way to do it is if we do create view. Remember views? This is a way to save a query. So we can create view, we give it a name. So we'll call it total by sale. And then we say create that as this query. And that allows us to select star from total by sale. All right. And now, whenever we need that information, we can just do I have to do this? Might have to do this. Okay, did I forget the view syntax? I might have forgot the view syntax. Views. Create view as select. Create view name as select. Okay. Pretty sure that's what I had, but it's mad at me, so we'll see. Oh, did I forget a semicolon before it? Let's see. That's not the right one. We're on this one. Probably just forgot. No, it's the first thing. Oh, I forgot the semicolon here. There we go. Okay, and so now I created the view of the result of this query. So anytime I need this information in this format, I can just call it like this, and the computer will rerun this query to get the information. So let's say I want to find the average of all of these. That's where we'll use another aggregate function. Okay, I don't think, do I need any of these anymore? No. It's so interesting for me to see how I did this years ago, and now that I've done it so much, how much more efficiently I can write these. Okay. So we want to select the average of tote. That's what we called the field here. And we can see the result there. The average of tote. Okay. And we want to grab what table do we, what information do we want to use? Well, the result of total by sale. And so this is much more concise. So we created the view here, so we only had to write the gross code once. And then if we ever want to use it again, we can write it concisely like this, because you can just use the view. And so here is the average of all of these numbers. So, we could find our max, we could find our minimum too, so we can see, oh, what did we do on our best day? What did we do on our worst day? Min, max, we can do worst as worst day, and this one as best day, and we'll do this one as average. Let's make it fancy. Average of sales. Oops. There we go. I just noticed I had to add these in, right? That's going to cause problems. All right. So we can see here's how much we made from each sale. Here's the average of all the sales. On the worst day, we only made 3,000. On the best day, we made 21,000. So what happened on this day and what happened on this day? That's really good business information. And we can, as we add more sales and line items, we can we're also storing date in sale. So we can use the where clause to say, okay, maybe for the month of November, what was our average sales for November? What was the best day? What was the worst day? And we can use that information to make important business decisions. And we just have to program it once, and then the developers can take that information, make it into an app, and the managers and the CEOs can get that information very quickly and make really good business decisions. So this is the point at which we started with you not knowing what a database was to how to write queries that would be directly used by a business to get information. Okay, if you're a programming major, you will be using this in your apps in the other classes, accessing data from a database. If not, this is useful for if you ever have to work with an Access database or any database, you'll be able to get the information from the data, from multiple tables, and by combining things together to get the exact answer you need. All right, I think that is it. I am going to update this, but if you have any questions, just shoot me an email. This is our last lecture, so I made a demo to help explain joins, and I'm going to make a video on that at some point, but let me know if they're still confusing to you, and I will see if you email me. And I guess you probably want to know about the final too. So save that so you have access to that assignment. It'll be the last assignment. The exam, let me check to make sure that it's up to date with what we've talked about. This is all pulled from the PowerPoint, I think. Okay, yeah. I'm going to go ahead and publish this, so you guys, you have until, I'll give you until the 16th by midnight to finish this take-home open book exam. Just some short answer questions, pulled from the material on the slides. Okay, yeah. All right, so go ahead and publish that. Alright, I'll have to make it an assignment. Anyway, I'll get that set up, and so you'll just download the document. If you don't have Word, I think you can open it in Google Docs. I'm okay with that. And then you'll just answer everything and then submit it. So. All right, well, have a good night, and I will see you guys, if not before the end of this semester, I'll see you next semester. You can always, over break, if you have questions about anything, you can always email me still, anything you need. All right, see you later.